Okay, so for those of you who are joining us online, you just missed a very dynamic networking session, and folks are just coming back into the room after coffee. In hosting an event like this, it really takes a lot of different parties, and one of the groups we'd also like to acknowledge in putting together both the organization and making this event happen is the Metropolitan Water District, who are very kindly sponsoring the refreshments throughout this event. So for MWD, many thanks for your support. As you're aware, there's both federal and state challenges to actually providing refreshments. So we greatly appreciate both your technical expertise and for hosting. One of the things we would like to do, clearly we also have a hosted event tonight. And just to give us a rough idea of how many folks are likely to attend this evening's event, could we just have a show of hands, please, to make sure that we don't run out of wine and all the important things? If you could hold up your hands just for a moment. Perfect? Okay. So it looked to me like almost everyone. So thank you for giving up your evenings this evening. The last plenary talk this morning is given by Paul Ramsey, who's Vice President and a geospatial architect with OpenGeo Suite, which is part of the Boundless Corporation. And Paul has over 15 years of professional experience providing technology development advice to organizations ranging from Fortune 500 firms at the large scale, very large government agencies and NGOs. So Paul, many thanks for being here today and sharing some of your experiences.
Thanks, Peter. So this is a talk, a manager's guide to open source, and I appreciate that not all of you are managers necessarily now, but there's a non-zero chance that you will be in the future, or at least you'll be giving advice to managers. I'd like to start, however, with a digression. One of my favorite pieces of poetry was delivered not by a beat poet in Greenwich Village or by a 19th century romantic, but by one Donald Rumsfeld, then Secretary of Defense, from the Pentagon Press Briefing Room on February 12, 2002. Hart Seeley later formed the Secretary's words into a poem, which was published in Harper's Magazine in June 2003 as The Unknown. As we know, there are known knowns. There are things we know we know. We also know there are known unknowns. That is to say, we know there are some things we do not know. But there are also unknown unknowns. The ones we don't know, we don't know. I've also found the same sentiments expressed less elegantly but more forcefully in diagram form, showing the stuff we know, the stuff we know we don't know, and the vast expanse of stuff we don't know we don't know. And it's scary that the largest category by far is the one that we definitionally cannot comprehend, the stuff we don't know we don't know. Of course, this is an epistemological diagram of all knowledge, so we can constrain it a bit by noting that for practical purposes, we're really only concerned with the stuff we should know. But unfortunately, the stuff we should know still falls in all three categories. And as managers and IT managers, there is amongst the stuff we should know, the stuff we should know about open source software. And I hope at this point we can all agree that open source is worth knowing about. The largest, most heavily trafficked companies on the internet have built their infrastructure on open source for practical, hard-headed business reasons. And open source is no longer just a technology fast follower. Leading-edge work in fields like software development tools, document search, big data analysis, NoSQL storage, these are being spearheaded by open source projects. And that's not because open source is just some kind of fad or something the cool kids currently consider trendy. It's because open source is a bona fide trend. It's a trend that's been building for over 30 years, changing not only how we build software, but also how we collaborate in building knowledge, science in general. So I bring two perspectives to this topic. The perspective of a developer of open source software, a hacker, a programmer, in particular on the Geospatial database, which I've been involved in for 10 years, and the perspective of a manager. I ran a small consulting company, Refractions Research, for a decade. So my goal today is to modify your internal epistemological diagrams a little, maybe to something more like this. And not because I expect you to all rush back home, rush back to the office, and implement open source, but because when you know more about open source, it becomes an option, and that's useful. It's useful to have more options. So to understand why open source is an option, it helps to have a bit of a background. So let's start with a little history. Once upon a time, there was a young man with wild ideas about freedom who took on the established order of things, appeared to lose, but in the end changed the world forever, though perhaps not in ways you would approve of. Actually, not that young man, although there was a striking resemblance. In 1980, Richard Stallman was a programmer at the MIT Artificial Intelligence Lab. And some of the best minds in artificial intelligence worked together. They shared ideas and implementations of those ideas in software, in code. And it was, to hear Stallman tell about it, a brief golden age of collaboration and intellectual ferment. And then one day, and don't all horror stories start this way, one day the lab got a new printer, Xerox 9700. Unlike the printer it was replacing, the new printer came with a binary-only printer driver. The source code was not included. Now, Stallman had modified the previous driver to send a message to users when the printer jammed. But with the new binary driver, he couldn't do that anymore. The situation, it was inconvenient. It was a pain. Why couldn't Xerox just share their code? Everyone would be happier. Now, most people might have shrugged, but for Stallman, it was a galvanizing moment. Over the past 5 years working in the AI lab, he'd grown used to sharing code and ideas with other programmers. But now the atmosphere in computing was changing. And it wasn't just the printer driver. A private corporation had started recruiting his colleagues in the lab. Once they were hired, they weren't allowed to exchange code with them anymore. The old computers in the lab and the software that ran on it were becoming obsolete. The new computers included operating systems that were locked down. You had to sign non-disclosures just to use them. It was the death of the old collaborative community. And Stallman worried that the first step in using a computer was to promise not to help your neighbor by accepting a license agreement. So as a highly talented and idealistic computer programmer, Stallman wanted to see his work serve a larger purpose. And facing the death of his old intellectual community, he asked himself, was there a program or programs that I could write so as to make a community possible once again? You can't use a computer without an operating system. So Stallman decided that first, he needed to write an operating system. It had to be portable to many computer platforms. It should be compatible with the popular new UNIX operating system. And most importantly, it should be free. Now, by free, Stallman meant that you should be free to run it. You should be free to modify it. You should be free to share it. And you should be free to share your modifications. In a Latinate language like French or Spanish or Italian, it's more obvious. Stallman isn't talking about price. He's not talking about logiciel gratuit. He's talking about logiciel libre. He's talking about software libre. He's talking about software libero. He's talking about liberated software. Right? The key addition is liberty. So in 1984, rather than join a computing industry he considered morally bankrupt, Stallman decided to basically start a new one from scratch. It was an audacious plan. Stallman called his new system GNU, which stands recursively for GNU's not Unix. You see the recursion? What's GNU? GNU's not Unix. Yeah, but what's GNU? GNU's not Unix. Computer programmers love that. Let me just take a very minor diversion here to add some extra flavor. In order to ensure that GNU remained free and did not get subsumed into a proprietary system in the future, Stallman released his work using a scheme he called copyleft. So, generally speaking, intellectual works, books, movies, songs, computer programs are either under copyright or public domain. The author either retains full control over the work, all rights are reserved, or no control, no rights are retained. Copyleft, And open source licenses in general use the copyright system to selectively grant permission and exert control over software through licensing. The authors retain copyright but grant liberal usage rights via license. So the copyleft license grants permissions to all recipients of the code to use, modify, or distribute the work in any way they wish, with one exception. The license requires that any redistribution of the work or derived products, including the source code, be subject to the same license. The legal language can get complex, but the principles are hardly foreign. Share and share alike. Do unto others as you would have them do unto you. Okay, back onto the highway. 1984, Stallman quits his job at MIT, starts working on GNU full-time. No visible means of support. It's a labor of love. But where to start? From a blank canvas, you want to create a completely free software ecosystem. What do you do first? If you wanted to build a 100% all handcrafted house, you would start by handcrafting your tools. And Stallman did the same thing with GNU versions of software development tools. He starts by writing a text editor, GNU Emacs, so he can write his free system using only free tools. The Emacs editor proved so popular, and internet access is still so rare, that he's able to earn a small living selling taped copies of the code, distributed under the copyleft license, of course. Then he writes a compiler, GCC. You can still find GCC in every Linux distribution. It's also in Mac OS X. Stallman lives like a monk. He works like a demon. He attracts some followers and helpers who formalize the project in a foundation. By 1990, they've got most of the components of an operating system. And most importantly, they have a full programming tool chain: shells, compilers, debuggers, editors, core libraries, and so on. All the things you need to write complex software. What they don't have is a Unix kernel, the piece of software that talks directly to the hardware. At this point, all their free tools are still being run on proprietary Unix. Okay, short detour. In 1991, a Finnish computer science student named Linus Torvalds buys a new computer, an Intel 386. So as a student at the university, he has access to Unix systems, and he wants to run Unix on his home computer. This is not possible. The good implementations for the 386 cost more than the computer itself. The cheap implementations, Minix, is quite limited. So Linus writes his own kernel. He uses Stallman's GNU tools to write and compile it, and in August 1991, he posts the following on an internet discussion list. Excuse my Finnish accent. Hello everybody out there using Minix. I'm doing a free operating system, just a hobby, won't be big and professional like GNU for 386 AT clones. This has been brewing since April and starting to get ready. I'd like any feedback on things people like or dislike in Minix, as my OS resembles it somewhat. Same physical layout, so on and so on. I've currently ported Bash and GCC, and things seem to work. This implies I'll get something practical within a few months, and I'd like to know what features most people would want. Any suggestions are welcome, but I won't promise I'll implement them. Smiley face, Linus. So, underneath the technical language, notice the subtextual bits. The humility, right? This is just a hobby, nothing big. The interest in other people's ideas. What do you like? What do you dislike in Minix? The posting is an invitation. Does anyone else want to come out and play? Does anyone? They do. Within 15 minutes, he has a reply. Tell us more. Does it need an MMU, a memory management unit? How much of it is in C? Within 24 hours, he has replies from Finland, Austria, Maryland, England. In a month, the code is on a public FTP server. Within 4 months, it's so popular an FAQ document's been written to handle the common questions. Linus Torvalds tapped a seam of enthusiasm that was just dying to express itself. People who loved computers and computing just wanted to play together. And through the medium of the internet, using only the simplest computing tools, diff, patch, FTP, and email, he built a community of thousands of contributors, and together they built a usable operating system. Now, something important happened between the time that Stallman started the GNU project and when Torvalds released Linux. The values of collaboration were the same, but the opportunity to exercise those values was far greater via the internet. When Stallman started GNU in 1984, there were 1,000 hosts on the internet. When Torvalds started Linux in 1991, there were over 400,000, and the pool of contributors was in the midst of a massive expansion. Permit me one more short digression on the digression to talk about Star Wars. And in particular, a website called Star Wars Uncut. Star Wars Uncut has taken the original movie and chopped it into 407... Oh, I lost my video. Aww. And I told the video guy it would work. Taken the original movie and chopped it into 473 15-second scenes. Each scene, then they separately reclaim it, and the members enact the scene and upload it. And the result looks like, not like that, it looks like lots of little 15-second scenes. It's really cool. It seems like a frivolous use of time. And maybe it is. It's probably pretty frivolous. But how do they manage to do this? How was this frivolous collaboration possible? And why did it only happen recently? Like, why did it not happen 15 years ago or 20 years ago? And Star Wars has been around for a long time. And there are just as many Star Wars nerds 10 and 20 years ago as there are now. What's changed? Well, first, the activity requires easy access to video recording and editing tools. And until recently, cameras and video editors were really expensive. It also requires enough bandwidth to download and upload video. And until recently, people didn't have that kind of bandwidth in their homes. And finally, it requires Star Wars geeks. But generalizing then, to build a large collaborative project, you need tools freely, or at least very cheaply, available, and you need sufficient connectivity between participants, and you combine that basic infrastructure with community and collaboration and love for the subject matter, and magic happens. There's many, many more examples of this kind of group collaboration. The academics call it commons-based peer production. But open source software in general and the Linux project in particular are some of the earliest examples of internet-mediated commons-based peer production. You may have heard of Wikipedia or OpenStreetMap. These are millions of people collaborating over the internet to build rich, valuable collections of knowledge. It's not a fad. It's the new normal. Complex structures of knowledge being built by distributed communities using free tools, held together by a shared interest, emotional or financial, in the product being created. And the proof is already here in our software, in our encyclopedia, in our maps. The development of Linux fits the commons-based peer production pattern. The free access to tools is provided by the GNU project components, editor, compiler, Lexer libraries. The medium of communication was just email. And the work they were sending around was source code, snippets of text, no problem for dial-up internet connections in the early 90s. And why do open source programmers do it? What's the core motivation? It isn't money. Fundamentally, they code because they love it. It's the same reason that Star Wars geeks reshoot 35-year-old films, or food geeks post restaurant reviews, or car geeks rebuild 68 Camaros. It's an avocation. At least it starts that way. But open source software has a wider utility than restaurant reviews and vintage muscle cars. So as projects have expanded, they have at each stage become more and more integrated into the wider community. So Linux is a good example. You start with Linus and an early group of enthusiasts, 1991. These are just individuals. They're working in their spare time. They're doing it for love. By 1992, you get distributors. They're packaging up the Linux kernel with collections of GNU software and tools to form a full working operating system. They're covering their cost and time. They're selling CD-ROMs for $50. So programmers are earning small livings on Linux businesses within a couple years of the project start. In 1994, Digital Equipment Corporation sends Linus a free Alpha workstation in the hopes that he'll port Linux to the Alpha chip. He does. So Linux is now competing with real Unix on corporate big iron. Over the next couple years, the makers of these machines start to hire Linux programmers of their own. In 1995, Red Hat Linux is formed. It's a company which eventually grows to a $8 billion Linux support enterprise. In 1996, Los Alamos National Labs builds the first Linux cluster to simulate atomic shock waves. It is 10% the cost of a comparable supercomputer when it's turned on. By 1998, the explosion of the internet into general public use is underpinned by thousands of commodity servers running Linux as their operating system. Microsoft is drafting strategy memos about how they're going to counter Linux. Linus Torvalds is on the front page of Forbes magazine. Linux is no longer a hobbyist activity. It is deeply embedded in the economy at multiple levels. And this is 1998. This is just 7 years after the first newsgroup post. Fast forward to the present. The NSA employs Linux programmers to make their systems secure. NASA employs Linux programmers to run it on space mission hardware. Google employs Linux programmers to optimize their massive compute clusters. Oracle employs Linux programmers to support Oracle-optimized Linux. IBM employs Linux programmers to ensure it runs on systems at mainframes. Microsoft even employs Linux programmers to add kernel support for Windows virtualization, and so on and so on and so on. So, here's a question I get asked a lot. How do you make a living writing free software? Referring back to the previous slide. Hopefully it will be obvious, right? I make my living the same way my dentist, my barber, my plumber make their livings. I sell my very specialized expert services in open source spatial database programming to people who need those services. And in a globalized, internet-connected world, there's plenty of people who use my software and want my services. But enough about me. What about you? Should you use open source? Here are 5 good managerial reasons, not technical reasons, managerial reasons to consider open source in your enterprise. I like technical reasons, but I'll leave those for another day. Managerial reasons. 1, cloud readiness, also known as scaling, also known as rapid deployment. License liability, or actually lack of same. Flexibility, and its kissing cousin heterogeneity. Staff development and recruitment, and most importantly, market power. So reason number 1, cloud readiness, also known as scaling, also known as rapid deployment. It looks like I'm squeezing 3 topics into one, but I'm not. These 3 benefits are all actually aspects of one open source attribute, the $0 cost of capital deployment. Always on the trailing edge of the leading edge, Microsoft once told us to look to the cloud. More and more computing tasks are going to be delegated to clouds of computers hosted in huge data centers somewhere on the internet. More users are going to expect direct access to data through web services. That means more mobile devices will consume services with every passing year, and all that new user demand adds up to potentially unconstrained load on services. And the growth curves transition very quickly from horizontal to vertical as services move into the mainstream. So scaling services is important, and it's getting even more important. So I'm the principal developer, did a little digression, I'm the principal developer of the PostGIS open source spatial database. And one of the things I have noticed over the years about PostGIS users is that the most enthusiastic adopters have been startup companies. Globe Explorer based their satellite image service on PostGIS, choosing it over Oracle and Informix. Redfin built their real estate site on PostGIS. MapMyFitness developed a mobile fitness application based on PostGIS. The Google Analytics for the PostGIS website show that California is the state with the highest level of interest, and inside California, it's San Francisco and Silicon Valley that have the highest interest. The reason startups love open source is because it removes a critical constraint on their growth. Well, the cost of computing hardware falls dramatically year after year after year. The cost of proprietary software does not follow the same curve. And if you're using software licensed per CPU or per core, that means the primary driver of scaling cost is software cost. And the math can be brutal even before you start scaling horizontally. So this Dell T710, actually no, this is the T620, excuse me, dual quads, core CPUs, 36 gigabytes of memory, 3 terabytes of RAID 10 will set you back $5,290. That's a pretty good deal. Let's put Oracle Enterprise on our fancy new server. We have 8 cores. Multiply that by a 0.5 processor core factor times the per processor price of Oracle Enterprise. Add in spatial, because we're doing geospatial stuff. And the grand total is $260,000, or as Larry Ellison calls it, $250,000. Just contemplate the numbers for a moment. So now it's possible you're already so highly evolved that you run your public services in the cloud. So there are no capital costs for servers, but the math in the cloud remains just as unpleasant. Per instance proprietary software licensing dwarfs the per instant hardware cost in the cloud. The only difference is the hardware costs are spread out more evenly over time instead of being concentrated into big capital intensive bursts. Managerial reason number 2, license liability, lack of. So before I was a programmer, I was a manager. Figure out that career arc. I used to run a consulting company, and at our peak we had 30 staff. It was a small company. But still, that meant we had 30 workstations under 30 desks running 30 licensed copies of Windows and 30 licensed copies of Microsoft Office. At least that was the theory. In practice, the company had grown very quickly over a couple of years, and the software, particularly application software, had just been installed wherever it was needed, whenever it was needed. So when we finally got around to counting up the difference between what we were using and what we owned, it was a bit shocking. We had 10 licenses of Windows and 5 for Office. Coming into compliance would cost almost 20 grand. Not coming into compliance would risk hundreds of thousands of dollars in fines. We were basically one disgruntled employee away from a big cash crunch. So we examined what we wanted our software to do. Our developers needed Java development environments. Our BAs needed document processing. Our managers needed some word processing. Everyone needed email. So we switched to open source. Everyone got OpenOffice for word processing, email, web browsing, switched over to Firefox and Thunderbird. Some developers switched to Linux as their operating system. And we bought a few extra Windows licenses to come into compliance. But the core point here is not that proprietary software is replaceable, though it often is. It's that proprietary software adds a layer of legal liability that needs to be managed. And that takes time and effort, because software gets copied a lot. And why wouldn't it? You can make a perfect copy with 2 keystrokes. Control-C, Control-V, Control-C, Control-V, Control-C, Control-V. And if that software is proprietary, each of those keystrokes digs a compliance hole for the organization. Click, click, click. Deeper and deeper and deeper until, and you don't realize how deep that compliance hole is until you fall into it. Number 3, flexibility and heterogeneity. So this is a bit of a geeky argument. Bear with me. First, flexible components are easy to connect to each other and to adapt. You can use flexible components from multiple vendors to build a heterogeneous system. A heterogeneous system incorporates components from multiple sources. Now, flexibility is great, but usually you have to trade some ease of use to get it. Which toolbox would you rather work with? The hex tool, convenient, easy, fits in the palm of your hand, 3 sizes, or the socket set, modular, extendable, 64 sizes, metric and imperial. One's easy, one's flexible. Here's a practical example of the value of flexibility and heterogeneity. I'm from British Columbia. The British Columbia government built their web mapping infrastructure back in the day using ArcIMS for their internal web services and web applications and MapServer for their external WMS services. So 2 mapping servers. Both mapping servers pull their data from a central ArcSDE instance. So they have a flexible tool in MapServer, and they have a heterogeneous infrastructure using both ArcIMS and MapServer. A few years ago, the infrastructure team applied a very tiny, minor service patch to the Oracle database that hosted ArcSDE. And to their surprise, that minor patch locked up SDE. They couldn't restart, which meant that their web services that depended on ArcSDE were also down. The WMS services were brought back up in 3 days after a long process of loading the raw data into a temporary PostGIS database. And it worked because MapServer could read from the PostGIS database just as easily as ArcSDE. There was no problem. The ArcIMS services remained offline for the duration of the outage, which was 28 long days, until a patch to ArcSDE was finally made available. As a general proposition, proprietary product lines talk well to each other. Systems from the same vendor, and less well to systems from other vendors. Competitive advantage dictates this arrangement, but it puts the interests of the customer in interoperability below the interests of the vendor in promoting lock-in. As a general proposition, open source products talk well to all other systems. The reason why is less obvious, but it has to do with the practical motivations of the developers. Once a project moves past the for fun stage, the developers are working on it because they need a workplace tool. They need it to do something, and the something they need it to do is usually within the context of other software. So as a developer, if you like MapServer's GML support, but you work in an environment where all the data resides in ArcSDE, the reasonable thing to do is to write code to connect the two. And each of these practical interconnections increases the overall value of the project. They bring in more developers who bring in their own unique interconnection requirements. Indulge me in a short digression. This is the boreal forest around Prince George, British Columbia, where I grew up. It's not really there. In the mature forest, out of the creek valleys, about 80% of the trees are pine and spruce. In the late 1990s, an infestation of the mountain pine beetle began in Wells-Gray Park in northwestern British Columbia. The local infestation turned into an epidemic over the next few years. The epidemic has been uncontrolled for a decade now and is only forecast to abate within the next couple of years when the population of mature lodgepole pine has been completely digested. Here's a graph of the number of hectares affected over time. The pine beetle has been so successful, for lack of a better word, not just because climate change has reduced the number of cold winters that kill beetles, but also because of its good luck in finding a huge, homogeneous area of mature boreal forest ready to consume. It's the product of 50 years of successful forest firefighting. Just a little digression on the digression. Computer worms are pieces of code that self-replicate, kind of like beetles. They start from a host, they scan for other vulnerable hosts, and they copy their children to that new host where the process continues. This is the infection timeline for the code red worm, which spread through a vulnerability in Microsoft IIS. Looks familiar, huh? Okay, let's go back on the road. Homogeneous systems, single vendor strategies, they are usually convenient, but there is a trade-off. They lack flexibility, which can make it hard to adapt them to unexpected purposes, and they present reliability risk, an increased vulnerability to population catastrophes, issues that are capable of shutting down your whole infrastructure in just one go. Reason number 4, staff development and recruitment. So one of the most gratifying things I've heard over my career, I teach about open source GIS, I give talks, and people come up to me afterwards and they say, that talk you gave last year, that talk totally changed my life. They're saying this about a software talk, right? It's just a totally absurd thing to hear about a software talk. And yet, I have been told this several times. The people saying it are the technology staff and GIS departments. And the reason they say it is because adopting open source gave them a whole new toolbox to solve problems. And the exhilaration of learning what was in that box and the freedom to use that knowledge to make cool things without external constraints like licenses on what they could make was deeply empowering for them. These are very special people. They are the kind of people you want to hire. I recently came across a diagram that explains it all on one page. You take the personality traits of intelligence, obsession, and social ineptitude. People with intelligence and obsession are geeks. Inept, smart ones are dweebs. The inept obsessives are dorks, and those with all 3 traits in the middle are nerds. So as managers, as IT managers, building out new systems, pushing the envelope, you probably want smart folks with a mapping technology obsession, geo-geeks ideally, but you could settle for geo-nerds. So how do you get these geeks and nerds to work for you? Offer something interesting. Remember, these are technology obsessives. Permit me a short digression to talk about Lisp. Paul Graham is a Silicon Valley entrepreneur and a major league nerd who tells this story about building his e-commerce site that he eventually sold to Yahoo in the late 90s. For personal technical reasons, they wrote their e-commerce engine in Lisp, which was a rare choice since most mainstream use of Lisp had disappeared by the late 90s. But using Lisp had this odd side effect, which was that when they advertised job openings, they got these amazing resumes. They got these rock star candidates, and when they interviewed them, they all mentioned their interest in Lisp. So by the 90s, Lisp was really mostly used in academic settings, but it also retained a prominent role as a customization language for Emacs, Richard Stallman's text editor for superprogrammers. So the super nerd programmers who obsessed over Emacs Lisp macros were intrigued by the chance to do web development in Lisp. Okay, so you're not going to build your websites in Lisp. I'm not recommending that. But you might build them in Python or Ruby. You might run them on Linux. You might serve them with map server or GeoServer. You might store your data in PostGIS or PostgreSQL. You might build your web pages with JavaScript and open layers and GeoXT. This does work in the real world. The city of North Glen, Colorado, they wrote a report about their experience with open source, and they cited some of the motivations I'm talking about. But in the section, I love this title, the section on unobvious motivations for adoption, there's this quote. Contrast an open source implementation position with a defined skill set job, where the first diagnostic action is to reboot the server, and the second is to call the vendor and wait in a telephone hold queue. It's easy to understand why open source jobs are prized. Finally, market power, number 5. So I haven't given a deeply technical talk today, so I haven't really run through the panoply of open source geospatial software that's available to you. But let me just quickly do that for effect. So for databases, you have PostGIS, MySQL, Ingress, SpatialLite. For map and feature servers, you have GeoServer, MapServer, MapNIC, TinyOWS, SharpMap, and others. For tile caching, you've got TileStash, MapProxy, TileCache, and others. For web interfaces, you've got OpenLayers, OpenScales, Leaflet, Polymaps, and others. On the desktop, you've got GVSig, UDIG, QGIS, OpenJump, MapWindow, and others. And underneath it all are libraries like GEOS and Google and OGR and Proj4 and JTS and GeoTools, which can be leveraged with scripting languages like Python, Perl, Ruby, Groovy, ASP.NET, and others. It sounds complex, right? And I have a survey talk, which 8 years ago was like a quick 20-minute talk. It has now morphed into like a 90-minute marathon where I cover all these options in detail. And afterwards, exhausted people come up to me and they say, open source offers too many choices. It's easier with just one vendor, which is odd because we deal with lots of choice in all the other markets we navigate every day. There's lots of kinds of cars. There's lots of kinds of blue jeans. There's lots of kinds of coffee. And we have a good idea about what a market with just one vendor looks like. We actually have laws against it. Proprietary software has a dirty little secret, and it's a dirty little secret that lives in plain sight. Even in otherwise competitive markets, the effect of proprietary licensing is to create an instant de facto monopoly. How many companies provide support for your proprietary software? 1. How many companies provide upgrades? 1. How many companies provide enhancements? 1. Proprietary companies guard their aftermarket monopoly zealously. In 2010, Oracle sued SAP for providing service patches and support to Oracle SAP customers, and there's a good reason Oracle sued. The profit margin for Oracle support is 800%. It's all about market power. Open source vests the market power in the software user, not the vendor. So as a manager, you probably don't care about tinkering with the internals of your software source code, but you should care about holding on to your market power as a customer. Bob Young, the founder of Red Hat Linux, asks this question of customers. Would you buy a car with its hood welded shut? No, right? No. So ask the follow-up question. What do you know about modern internal combustion engines? And the answer, for most of us, is not much. But we demand the ability to open the hood of our cars because it gives us, the consumer, control over the product we've bought, and it takes it away from the vendor. We can take the car back to the dealer if he does a good job, if he doesn't overcharge us, if he adds the features we need, we might keep taking it back to that vendor. But if he overcharges us, if he won't fix the problem we're having, or if he refuses to install that musical horn we always wanted, there are 10,000 other car repair companies that would be happy to have our business. Making an enterprise commitment to a single vendor puts you permanently into the worst negotiating position possible. You go into every negotiation with no alternative position other than to storm off. The only leverage you got left is the threat to buy nothing at all, which isn't much of a threat. So to maintain market power, to provide our staff with new growth opportunities, to build heterogeneous systems, to lower license liability, to be ready to scale, for all these reasons it makes sense to have open source as an option. But how to start? We'll need a Simpsons hand for this one. So to get started, you should first experiment with open source on pilot projects, then integrate open source into your existing operations, then evaluate open source alternatives yourself. Don't take other people's word for capabilities, and expand the capabilities of open source to do what you need done. So we're running out of time. We'll take the first two at once, experiment and integrate. Way back in 2007, Pierce County in Washington State, at that point, they were a 100% Esri Microsoft shop. Limited budget for new software acquisition. They did have some talented technical staff and a GIS manager who was interested in new ideas. So in the fall of that year, she learned that the International Open Source GIS Conference was being held just to the north in Victoria, and she took the opportunity to send several of her staff. Keep an eye out for alternatives, she told them. And when they came back, they had lots of alternatives, and they were very excited. But they couldn't just tear down their infrastructure and start again. They had to maintain service continuity. So the team started experimenting, duplicating some existing services that were built using old MapLogix technology and slated to be replaced anyways. Some of them were very simple services, minimal user interface, like this critical areas query form. Just takes a parcel number and address, returns a simple report on environmental factors based on a query of 18 layers. MapObjects was unstable, ArcIMS was too slow, but open source, PostGIS in this case, was just right. The form actually didn't change at all, just the back end. As their confidence in the tools grew, they looked at migrating core bits of infrastructure. More recently, they replaced their SQL Server with PostGIS and PostgreSQL. The key here is that they're continuing to run ArcSD on top, and this allows them to keep using their existing data management tools like ArcGIS. But they also can use a pure open source web services stack directly against PostGIS. So the changes are incremental and exploratory. Pierce County still runs Esri software, ArcGIS desktops, but the number of options they have for deploying new systems is higher. The number of licenses they require is going down, not up, and budget flexibility is increasing. At the same time, the staff has enjoyed learning the new technology. There's actually a great opportunity this year for you to duplicate the Pierce County experience, as that same conference, FOSS4G, is located quite close by this year in Portland, Oregon, in September. So Pierce County experimented with a limited number of open source components, PostGIS, GeoServer, OpenLayers. But as we saw earlier, there's lots of choices in every product category. So how do you choose the product that is right for you? What are the criteria of evaluation? A guy named David Wheeler has a very complete document called How to Evaluate Open Source Software. Much of the evaluation criteria is the same as proprietary COTS, commercial off-the-shelf software. You look at if the software does what you want. You look whether it works with the software you already have. But some key things are different. In evaluating longevity, for instance, you won't be able to look at the revenues or the customer count of a company. You'll look instead at the history and activity of the community around the software. Is it a big, vibrant community? And most importantly, you'll have to do the evaluations yourself. There won't be sales reps. There won't be snappy PowerPoint presentations, except for this one. And there won't be sales material or brochures. You'll probably have to download, install, and test the software yourself. But this is a good thing. This is a feature, not a bug. Trying the software yourself will give you a reality-based understanding of its features, capabilities, and weaknesses, rather than a marketing-based understanding. I always get taken in by the glossy brochure. But suppose you evaluate and the software that meets most of your criteria is missing a key feature. What then? Open source often has a lower feature count than proprietary software, but unlike proprietary, adding the features you need is not impossible. You might want special purpose features for your project, like this list of obscure functionality. A vendor would never add those because there are too few customers to want them. However, these are all examples of features that I added on services contracts to customers from Australia, USA, Spain, Germany. All of them were added to the community source code, and all are still present in releases today. In contrast, if you want to get a feature added to Oracle Spatial, you could become the Secretary of Defense, and then you could lean on Larry Ellison while yachting. If you want to get a feature added to PostGIS, you just have to give me $2,000 to $10,000 and wait 2 to 6 weeks. This is a new way of thinking about enterprise software, not just taking it as is, but pushing an open source project in the direction you need it to go. It's a layer of flexibility you don't have in the proprietary world. Now, it's hard to adopt this new way of thinking about software, but it's part of getting started in open source. You've got to experiment with your pilot systems and integrate them into your existing systems. It's not going to be a big 100% turnover, a little bit at a time. You have to evaluate it as you do it with hands-on work and expand the software the way you need it to go and expand the way you think about software. The benefits will be greater scalability, lowered license liability, greater flexibility, more empowerment of your staff, and more market power for your organization. Because open source is not going away. It's not a fad. It's the new normal. Sharing code makes sense for individuals. It makes sense for organizations. The only people it doesn't make sense for is the existing legacy software vendors, which is too bad for them. Because open source culture is just business as usual on the internet. It's collections of people and organizations with shared interests, financial and social, using open tools, open licensing, to build the software and the knowledge they need. Thanks very much for having me. I'll be here the rest of the day. I look forward to talking to you.
Thank you, Paul. I think we've got time